Hi everyone, welcome to Mathworld. This is Cambridge International AS and A-Level Further Mathematics Paper 2 for October-November 2022, and the code is 9231/22. Okay, so this video I'm going to show you the solution of question 3 and 4. So let's move on to the question 3. So now, this question 3a, the curve has equation y equals to ex plus 1 over 4 e negative x, whereby the x from 0 to 1 inclusive both values. Find in terms of r pi and e the area of the surface generated when the curve is rotated through 2 pi radians about the x-axis. Okay, so just for your information, the formula for surface area, it is 2 pi integrate y square root of 1 plus square of dy dx squared. Square of dy dx, then dx. Okay, and we need to integrate from 0 to 1. So this is our formula because of the x-axis. Therefore, we have to integrate with respect to x. So due to this reason, it's better for you to get the dy dx first. All right. So I will start with y equals to ex plus 1 over 4 e minus x. So when you need to differentiate e mx plus b, right? So the formula is basically me mx plus b. So this is the formula that I'm going to use to differentiate the y. So now dy over dx, differentiate ex, you will get back ex, because when you differentiate x, this is basically 1. So same for the next term, plus 1 over 4 e minus x, it will be negative 1 over 4 e negative x. Right? So now, we may square the dy dx first before you substitute into the formula. So when you square these two terms, right, you will be getting e2x minus half plus 1 over 16 e negative 2x. Okay, so now let's substitute into the formula. So your s is 2 pi integrate 0 to 1. Your y is ex plus 1 over 4 e minus x. And this whole terms, right, these two terms multiplied by the square root of 1 plus square of dy dx. So e2x minus 1 over 2 plus 1 over 6 e negative 2x. Then dx. Okay, so now for the square root, we try to simplify so that it can be expressed in terms of squared, then the square and square root can be cancelled off. So now, rewrite the first two terms. Okay, then you get square root. Now, 1 minus half, I will be getting half. So I will rewrite the exponential to x. Then the second term becomes plus half. Okay, so now, when you check, square of minus, it will be minus half in the middle. So now we are getting plus in the middle, which means this is basically square of the positive. Okay? Which means you are getting square root. These three terms, I can modify from the dy dx squared. Right? Square of dy dx. Instead of minus, I change to plus. So I will get ex plus 1 over 4 e minus x squared dx. Okay, so now, from here, obviously the square and square root will be cancelled off. Then, I will have to expand these two terms. But these two terms are the same terms, right? Therefore, when you multiply itself, it will be square of the bracket, which is the ex plus 1 over 4 e minus x. So when I do expansion, I will get e2x plus half plus 1 over 16 e negative 2x dx. So now, to integrate e mx plus b with respect to x, we will always rewrite the whole exponential, and then differential ms plus b, it will be over m, then plus c. This is the formula that we are going to use. Now, I will get 2 pi, integrate e to x, it will be e to x over 2, plus half becomes plus half x. Then the next term, it will be 1 over 16, then e negative 2x over negative 2. So, limits from 0 to 1. Okay, so now, I can simplify all the half together with the 2. So, before I replace the x values. So, now, replace the x by 1, I will get e squared plus 1. Then, minus, okay, don't forget the minus over here, minus 1 over 16, e negative 2, then minus, bracket. Now, replace the x by 0. So, e0, I get 1. Then, second term will be 0. Third term, 1 over 16. Okay, so now, when you refer back to the question, it mentions that you have to leave your answer in terms of pi and e. Okay, so now what we do here is, we write the pi. So keep the e squared. And then the third term, 1 over 16 e negative 2. The negative 2 degree means that you can bring down the e. Okay, so I will going to bring down. It will be 1 over 16 e squared. Now, for the rest of the constants, so the second term 1, fourth term is minus 1. So it will be cancelled out. And then don't forget there is a minus outside the bracket. At last you are getting 1 over 16. Okay, so this is the solution for A. Right? So now let's move on to next part. Now, using standard results from the list of formula, or otherwise find the Maclaurin series for exponential x plus 1 over 4 exponential minus x up to and including the term in x squared. So from the formula list, we know that ex is 1 plus x squared over 2 factorial plus plus x degree r over r factorial, if you refer to the formula list. So now, since this is up to x squared, therefore, okay, I will just write my expansion up to x squared, means I will stop here after the third term. Okay, so this is from MF 19. Right, so now, first term done. Second term here, e negative x. So I will write e negative x. So when you compare these two terms, the x here has been changed to minus x, which means in your expansion, all your x must be changed accordingly. Okay, so which means I will get 1 plus, instead of x, we change to minus x. Then the third term, we change to minus x squared over 2 factorial. Okay, so when you simplify, you will get 1 minus x plus x squared over 2 factorial. Okay, these two are the series. Now, final answer, ex plus 1 over 4 e minus x. So for ex, it will have 3 terms. So 1 plus x squared over 2 factorial. Then plus 1 over 4, 1 minus x plus x squared over 2 factorial. Right. So now, simplify. So 1 plus 4 over x, it will be 5 over x. That's right. 1 plus 1 over 4, it will be 5 over 4. Then here 1x minus 1 over 4x, it will be plus 3 over 4x. Now this x squared over 2 factorial plus with 1 over 4 times x squared over 2 factorial. At last, you will be getting 5 over 8 x squared. Okay, so this is the series up to x squared. Okay, so that's all for this part. Now, let's move on to next question. Next question is question 4. Find the solution of the differential equation 4t squared minus 1 multiplied by dx dt plus 4x equals to 4t squared minus 1. For which x equals to 3 when t equals to 1. Give your answer in the form of x equals to ft. So now, first of all, let me copy the question. Okay, so this is first order differential equation. So basically, we have two methods to solve this question. The first is separable variables, and the second is integrating factor. So the separable variable method is not applicable here, because to use that method, right, you need to move the 4x to the right side. But once you move the 4x to the right side, on the right side you will have the combination of t and the x. All right. Later on, you are not able to split the variables completely. Therefore, in this case, we are applying the integrating factor method. So based on integrating factor method, the coefficient for dx dt must be 1. Therefore, first step is divide the whole equation by 4t squared minus 1. Then you will get dx dt, and expressed in the general form of the equation. Okay, so you will get x bracket 4 over 4t squared minus 1. Then right hand side will be 1. So, and let this be the first equation. Then from here, you will be able to get integrating factor. Now, integrating factor is I, which is exponential integrate the coefficient for x. Okay, so now, when you refer to this integration, denominator is a quadratic, but numerator is a constant. Okay, so you can refer to the notes, the formula list. Actually, you can refer to square root 1 over x squared minus a squared dx. This is a formula that I'm going to apply. It will be 1 over 2a ln x minus a over x plus a. Okay, because I noticed that the 4t squared here can be written as square of 2t. Then I will replace the 2t by another variable so that it will be similar to this form. All right. So now, what we need to do here is, all right, e 4 over 2t squared minus 1 dt. So now, okay, I have found minus of 2 squares. So minus of 2 squares. The 1 is the same as 1 squared. But then, to use this formula, it must be positive x squared. Here, I'm getting 2t squared. So now, it's better for you to continue with the substitution method. So let u equals to 2t, so that I will change to u squared, right? Then my x will be the u. So now du over dt, it will be 2. And to get the dt move up, therefore half du will be my dt. Now, in order to use this formula, numerator is 1. Therefore, I'm going to factorize the 4 on top there, right? So e 4 integrate 1 over. So now, my 2t will be replaced by u. So u squared minus 1. dt will be half du. So you can write half du here. So now, the half and 4 can be simplified. So here, simplified to be 2. Right? So here e 2 integrate 1 over u squared minus 1 du. So when you compare now, 1 over u squared minus 1 du, it is the same as integrate 1 over x squared minus a squared dx. Right? Which means my a is 1. So when you compare, my x becomes u. So when I replace it here, I will get 1 over a, 2a, 2. So a is 1 means that 1 over 2 ln u minus 1 over u plus 1 according to this formula. So I will be getting e 2 Then 1 over 2 ln u minus 1 over u plus 1. Okay, so and again, the 2.5 can be cancelled off. Now, when you have e ln, basically it can be cancelled off, means that you are just getting u minus 1 over u plus 1. Okay, now, of course, you have to change back. Your u is 2t, right? So here, 2t minus 1 over 2t plus 1. So this is our integrating factor. And I will let this be second equation. So now, after this, you need to multiply second equation by first equation. So now, when I multiply second by 1 by first equation, so, and if you are confirmed that your I is correct, okay, this means this is correct, then the left-hand side, instead of these two terms, you can express in just the default form, which is d over dt, then x times the I. Okay, if you are sure that the I is correct. So, now for the right-hand side, there's a 1 here. So when 1 multiplied by I, it will be the I itself. That means my right-hand side is 2t minus 1 over 2t plus 1. Okay, so now to get the x, I need to move the d over dt to the right-hand side. So it becomes integration of 2t minus 1 divided by 2t plus 1 dt. Okay, so when you need to integrate this, basically you may use long division or polynomial division because of the same degree in the t. So I will get 2t minus 1 divided by 2t plus 1. So multiply by 1. 1 times 2t plus 1, you will get back the same terms. After that, you minus. First term will be 0. Second term is minus 1 minus another 1. So you get minus 2. So from here, I will say that it is 1 minus 2 over 2t plus 1 dt. Okay, so now I can integrate these two terms. So when you integrate first term with respect to t, you will be getting t. Second term, when you differentiate 2t plus 1, it will be 2. That means this is the ln of 2t plus 1. Then plus c. Okay, so right now you are getting this general solution. Now, you are given x equals to 3 and t equals to 1. And you need to leave your answer in x equals to ft, which means the x must be the subject. So now, with these two values, x and t values, you are expected to count the c, okay, to get the particular solution. So x equals to 3, t equals to 1. So now 3. So 2 times 1 minus 1, I get 1. Over 2 times 1 plus 1, I will get 3. Okay, t is 1 minus ln 2t plus 1, you'll be getting 3. So now, left-hand side, 3 times 1 over 3 is 1. So here 1, this is 1. So on the right side is also 1, which means your c is ln 3. Okay, so now replace, and at the same time to get the x, this term must be moved to the right side and swap. So now I will get x equals to 2t plus 1 over 2t minus 1. Then t minus ln 2t plus 1. Then the c is ln 3. Okay, but since you have 2 ln, okay, 2 ln here, we may simplify. So your x will be 2t plus 1 over 2t minus 1 multiplied by t. Now, to simplify the ln, okay, ln a minus ln b is ln a over b. So now this is ln 3 minus ln 2t plus 1. I can change to division. So it will be plus ln 3 over 2t plus 1. So this is the solution of question 6. Okay, first order differential equation. Right. So again, if you like my video, don't forget to subscribe to my channel and stay tuned for upcoming videos. Right. Thank you. Bye.